Okay, everybody. It's morning math, but we're going to make this video for you. Volume of pyramids and cones, volume applications. And notice I'm at Mr. Field Math. Unit 10 circles is ready for you. We just got to make the videos. And then you made it. It'll be time for Algebra 2. Exciting. And high school as well. Okay, so here we are. And of course, there's more than 3 weeks of school, so we're going to be doing some projects at the end of the year to put this math, connected to the real world. But first, let's look at this first volume quiz, actually from the 6th grade, and then 8th grade, and then high school. See, we got to dig back because volume has some, previous knowledge like this. How many vertices does the shape have? You can get your computer and start preparing for the MCAT. So vertices are the points. So we got 1, 2, 3, 4, 5. So it's the corners. That's what that is, the corners. We got vertices. Oh, let's write this down. Vertices are the corners. We have edges, we have faces. So edges are the side line segments. And then faces are shapes. So let's color code this a little bit. The faces would be like, that's the base face right there. The edges would be like that, and then the vertices, which I have already mentioned, are like all the little points. Okay. Okay, how about this one? That Christian put a large rock on the bottom of the terrarium he built for his pet turtle. The rock is a right rectangular prism, and it displaces that amount of water. How high is the rock? Oh, this is good. This is good. So first we must draw a picture. Okay, so we're going to draw a picture of a right rectangular prism. So the rectangular prism has a rectangle for the base, and then I draw my rectangular prisms like that. There's a right rectangular prism. Means that the base is a rectangle, and then it has a certain height. So we have we call it the length and the width and the height. And then a rock displacing that amount of water, that is the definition of volume. How much water could the thing hold? That's a way to say how much volume it has. How many square cube blocks could you put in it? Okay, so we know how wide it is, so that we can say that's 10. And over the W. And 12. Place that with the 12. And we don't know the height, so that's going to be our X, but we do know the volume. And so we always want to think of the volume of something. Volume is the base area times the height. All right, so don't think length times width times height, because then when we get to cylinders and other things, you will get a little bit confused maybe, all right? But think of it this way. So length times the width, that's because the base is a rectangle, and the area of a rectangle is length times width, right? So group it that way, and then you'll get all the areas of all the volumes of all the shapes, and not just rectangular prisms. So we are going to do length times width. We know 10 times 12, so the base area is there. The height is unknown. and the volume is 1800. So it's 120 H equals 1800. All right. 1800 divided by 120 is 15. So it's 15. Okay. Identify the 3D shape. That's a cylinder. Okay, so you can do the rest. Now let's go on to the volume of a cone. So we have two categories. We have the prisms and the cylinders. And then we have the pyramids and the cones. And we can think of all of them as base area times the height, right? Cylinders have a base of a circle, so it's pi r squared h. And prisms, it's whatever that the shape of the base is. It could be a triangle or a rectangle. And then you find that base area, multiply it by the height. Pyramids and cones, so they are also base area times the height. But as you can see, it gets decreases and decreases. And so actually for a cone, it works out that there's a specific fraction we can put in front and then still use our formula. And as you can see, that fraction is 1/3. For a pyramid, it is it depends on the shape of the base. Okay, it could be 1/2, but it's for the cone is 1/3 base area times the height. And so we're going to do that. We're going to do 1/3. Base area is a circle, so pi r squared. R is 6. H is 4. Now, if they give you the slant height, this is called the slant height. Do not use that to find the volume. We will use that next week for surface area, but not volume. We use the perpendicular height for volume. So you may need the Pythagorean Theorem. Does everybody see the right triangle here? All right, well, so they did not try to trick us. We are just going to go ahead and calculate. And then, I could do that, but I knew that was 12. Okay. Times 4, and so 4 times 12 is 48. So the exact answer is 48 pi. If I wanted to find the approximate answer, I can multiply that together times 3.14159. 14159. It's like 150.8. All right, but we're not gonna use the approximate volume when we know the exact volume. Right, that, and that's how we do that. Now, see, that's a cylinder. So you're just going to find the area of the base and then multiply by the height. Okay, so moving on to volumes of prisms and pyramids. So now you can see for this one, the volume of this figure. Now, hold on one second. All right, it's been a while since I did my volume formula, but I have good news for you. This is also 1/3. All right, even though it's a different shape of the base, I was like, I don't think the pyramid is 1/3, and I'm sorry, it is 1/3. All right, so we just have a different shape of the base. So that's all I had to write, and so that's what we're going to do again. So what is the shape of the base? It's a triangle right here. What are the base and height of the triangle. Right here. Notice they didn't give us, if they gave us this side, we'd have to do the Pythagorean Theorem to find out the actual height. But they gave us the height. So you know that that's going to be 1/2 8 times 6 times 1/3. And then what's the height of the pyramid? Is it 11 or is it 36.2? It is not 36.2. That is not perpendicular to the base. So the height has to be perpendicular to the base. That's 11. Okay, so this is 48 and half of 48 is 24. And then 1/3 times 24 is 8. And that's 88. Put my calculator down. Don't need my calculator. 88. Okay. So have fun with that one. Let's look at some high school geometry. So applying volume of solids. So really, when you get to high school geometry, we should be talking about applications of volume, but a lot of times the actual volume formulas are neglected. So that's why we have to do those. But now let's talk about application. An ice cream company sells their product in a cylindrical container, 16 cm tall and a diameter of that. They're considering switching to a new container who has a different shape of the base. Okay. The company wants the new container to have the same volume. How tall should it be? So let's make sense of the problem and draw a picture. We have a cylinder. This is a very good problem because it could actually happen. And they want to switch to a rectangular prism. Okay, so they want to go from that to that. The original is 16 tall. It has a diameter of 14, which means it has a radius of 7, right? They're considering switching to a rectangular prism that has 13 by 20, and they want to know the height, right? So how tall should the new thing be? Well, we want to know, we want their volumes to be equal. We never want to change the volume, just the shape. So let's find the volume of the first one since we have all those measurements. And then we will know the volume and we will solve for the height. This is just a nice little algebra problem. So what is the volume for a cylinder? We know it's pi r squared h. So substitute that in. 49 times 16 times pi. 49 times 16, 784 pi. So that's our volume. And now we're going to get for the prism, we know the volume is 20 times 13 times 8. And then we can substitute in our volume 784 pi. And let me just do 20 times 13. 260. Now divide both sides by 260. H is equal to 784 pi divided by 260. And the answer is 9.47. Round to the nearest cent, so 9.5. All right, let's see if we got it. 9.5. Okay, look at that. So we're just two volume formulas in one. Now the last assignment is density word problem. Word problem. So we need a new density formula. Here it is, right here. Oh, write this one down. Density is total quantity divided by volume. All right. So what do we know? So what is the density of the salt in the solution? So density is how closely compact something is, right? Air is less dense than a desk. So 7.5 liters of a certain solution contain 37 grams of salt. Okay, so we know the volume of a solution is 7.5 liters, and then we know the quantity is 37 grams of salt. So we just have to divide it. So it's 37 divided by 7.5. 4.93 repeats. And we're going to round to the nearest tenth, so that's 4.9. Don't worry, guys, I'm almost done. All right. To play basketball with the friends, Evangeline needs to pump air into her ball. She's completely deflated. Before inflating it, the ball weighs that many kilograms. Afterwards, that many kilograms. The diameter of the ball is 0.24 meters. Assuming the inflated ball is perfectly spherical, what is the air density within it? Okay, so volume of a sphere. We've not talked about the volume of a sphere. The sphere's volume is 4/3 pi r cubed. So write that formula down. And let's find the volume. We need the radius to do that. So we know the diameter is 0.24. Divide that by 2 and we get 0.12. So we can now find the volume of our sphere. So I'm just going to put parentheses 4 divided by 3 times pi times 0.12 to the third power. And I get 0.007. And we know that density is equal to the quantity divided by the volume. Is that right? So assume what is the air? If it's inflated, it's perfectly spherical. Before and then after weighs that many. All right. So does that mean that we have to subtract those two to get the total quantity? Is that right? Divided by 4. Ooh, subtraction on me. 0.624 minus 0.615. Oh, right, hold on. All right. Woo! I did everything right, but I second guessed myself because I thought that I had gotten 0.009 for the volume, but I got 0.007. And we just got our quantity is 0.009. So we're going to now divide our two answers, 007, and we get, well, I already know the answer now, 0.124. All right, so let's just review the hints here. As you can see, Mr. Field doesn't calculate density all that often. That doesn't mean it's not important. Just all right, so the density is total quantity divided by volume. And so we found the quantity by subtracting, and we also found the volume using our volume formula, and then we just divide. The answer 1.24. Oh, it is. All right. So go forth and post in the organizer. All right. Try all these assignments, just like I.